Hello, this is Mrs. Sturgeon here to talk to you about how to solve a quadratic by using square roots. So let's go ahead and get started. Now, basically, what we're going to do to solve these problems is we're going to use algebra to solve to get x by itself. So, as you can see here, what I would maybe do is pause the video and even just write down these steps, and it is basically how you solve the problem. All right, so we're just going to go through, follow the steps for the first example, do a couple more, and then that'll be it. All right, so first it says isolate the term that contains the squared variable. Okay, so what that means is we've got a term right here. It contains the squared variable. We need to isolate it. Okay, and you know what? Actually, I'm only going to highlight the x squared. We actually just need to isolate the x squared portion itself. So you've got this minus 104 in the way of this being fully isolated. So what I'm going to do is algebra, right? So I'm going to add 100 to both sides to get it away from being around that x squared. So now I'm left with 4x squared is equal to negative 100 plus 100. That cancels out. 0 plus 100 is 100. So 4x squared equals 100. Next, divide both sides by 4. I get x squared equals 25. So I've successfully now isolated the term that contains a squared variable. I got x squared by itself. That's what I needed to do. Next, it says take the square root of both sides. So that's what I'm going to do. Square root, square root. Okay, when I do that, if I square root x squared, I'm just now left with x. So x equals, now I need to actually figure out what is the square root of 25, right? So it says solve for the variable and include all possible answers. The reason that that is written in all caps is because of the fact that whenever you're solving a quadratic, you should get numerous answers. Okay, you might get one answer twice, you might get two totally different answers. There's going to be a lot of options here, but essentially the two answers that we are going to get positive and negative 5, okay, because if I were to take positive 5 and plug it back into the original equation, positive 5 times positive 5 is 25. Great. If I take negative 5 and plug it back into the equation, negative 5 times negative 5 is also positive 25. Okay, so it turns out that either of those answers work. So whenever you're solving by taking square roots, don't forget at the very end you see the symbol right here, plus or minus. That means that both positive and negative 5 are possible answers for this particular equation. Okay, let's do a couple more. Okay, so for this example, notice that x squared is already by itself. There's no number in front of it. There's no number being added or subtracted. So you can actually completely skip step 1. You don't need to isolate x squared. It already is. So all I need to do is square root both sides. Okay, then from there, again, square root of x squared is just x equals. So x equals, now the square root of 36 is 6. But remember, I need two answers here. Both positive and negative 6 would work for this. Because if I take positive 6 and square it, I get 36. If I take negative 6 and square it, I also get positive 36. So both of those answers work for this, and I need to list both. Let's do another one. This one will require a little bit more work, so I need to go ahead and isolate the x squared term first. So my x squared term is right here. Let's isolate it, get it by itself. Using algebra, if I add 9 to both sides, I get 9x squared is equal to 16 plus 9 is 25. Okay, next, divide both sides by 9. Okay, so x squared, you might notice that 25 divided by 9, that's not going to give you a nice answer. It's going to be some weird decimal. However, if I leave it as 25 divided by 9 as a fraction, this next step is actually going to go a lot smoother. Now, square root both sides, I get x equals, think of it this way, square root the numerator, the top, square root the denominator, the bottom, and both of those are individually perfect squares themselves. So the square root of 25 is just 5, the square root of 9 is 3, so my final answer is x equals positive or negative 5/3. Okay, so leaving it as a fraction was actually helpful there. Anytime you have two perfect squares, one on the top, one on the bottom, I would leave it as a fraction so that you can identify what the answer is a little bit faster. Let's do one more example. Okay, so again, first step, isolate the x squared term. So if I add 1 to both sides, start doing my algebra, 2x squared is equal to 48. Divide both sides by 2. I get x squared is equal to 24. Now, if I square root both sides at this point in the process, you might notice, well, 24 is not a perfect square. All the other answers have worked out pretty nicely for us, but now 24 it is not a perfect square. So I'm going to go back to what I know about simplifying perfect squares, or I'm sorry, simplifying radicals, and use perfect squares in order to do so. So I'm going to start by figuring out what is the biggest perfect square that will divide evenly into 24. And the answer to that question is 6. So I'm going to split this up into square root of 6 times square root of 4. And I think I said the biggest perfect square that divides into 24 is 6. It's not 6. 6 is not a perfect square. It's 4. Okay, so from here, I need to figure out, okay, which one of those is the perfect square? The perfect square is 4, so that means the square root of 4 is 2. So my final answer is x equals, plus or minus, don't forget your plus or minus, 2 square root of 6.